Welcome class to your second week of digital learning. This video is about vectors and it goes with your first two assignments on the platform Edgenuity. What is a vector? A vector is drawn right here. This is an example of a vector, and vectors have two quantities, magnitude and direction. So this is a vector. Let's call it vector V. We're going to call this guy vector V. So I'm going to label it with a V, and the symbol for vector is this little hat on top. It's like half an arrow. So the symbol for a vector is like an arrow, but without that little bottom bit there. Half an arrow. Okay, so this vector, vector V, has a starting point and an ending point. This vector goes 1, 2, 3, 4 units to the right, and 1, 2 units down. Well, these have direction, so this 2 units down is going to be -2. So we can say that vector V equals 4, -2. We symbolize a vector by using these pointed parentheses. So they're not rounded parentheses, they are pointed. And so I'm going to zoom out a little bit because this vector, vector V, is actually on the coordinate plane. It does not matter where a vector starts. I could place vector V anywhere I wanted to on this whole graph. In this case, vector V has a starting point of -12, 10, and an ending point of -8, 8. I can find vector V by taking the end point and subtracting the start point. So the way this would look, I'm going to take my end point, which is where the arrow is, it's where the vector is pointing, and that's -8, 8. And I am going to subtract my start point, which is -12, 10. -8 minus -12, well, minus negative, this will become +12, -8 plus 12, that's 4, 8 minus 10, that's -2, and notice how we got the amount for vector V. And so if you're given a start point and an end point, that's one way you can find the components of the vector. As I said, vectors can be placed anywhere. I happen to place this vector over in quadrant 2 here. The next thing I want to talk about is magnitude. Magnitude basically just means the length of the vector. So we can see this vector. I need to figure out how long it is. But look at that. We have a triangle here. So the way I'm going to find magnitude is by using essentially the Pythagorean Theorem. The magnitude can be symbolized with these two vertical lines. It looks a lot like absolute value, except there's two of them. And the magnitude of vector V is equal to the square root of 4 squared plus -2 squared. So y'all should recognize something there. Except I don't want you to use negatives. Don't use negatives. We can say that the magnitude of vector V is the square root of 4 squared plus 2 squared, and we can simplify this by hand. This comes out as the square root of 20. Further simplifying that, if I wanted to take 20 and break it down, I'm just trying to simplify the square root here, so 20 is 4 times 5, but 4 is a perfect square, so the square root of 4 is 2. A 2 comes out of the square root, and we wind up with 2 root 5. Root 20 is an acceptable answer. 2 root 5 is how some of your Edgenuity quiz answers are. So in case you need that, another way to go about that is you could enter root 20 in your calculator and 2 root 5 in your calculator, and if they're the same, then you have correctly found the magnitude of your vector. Another thing that I can do with my vector is something called scalar multiples. So I'm going to add a piece of paper here. So scalar multiples. Scalar multiples. Okay, so an example which can be done mathematically. Is I would like to find 3v. 3v. So I'm using the same vector v that I had right here. So 3v. This is the same thing as 3 times 4 comma negative 2, because that's vector v. And so as a result, I would get 12 comma negative 6. All I did, whoops, should be pointed because it is a vector. All I did was multiply 4 times 3, that's 12, and negative 2 times 3, that's negative 6, and this is my resultant. We can also find a scalar multiple graphically. So I want to find 3 vector v graphically. So I'm going to go back to my original drawing. Well, here's vector v. Now I'm going to draw vector v again right after vector v. So actually I can go to a different quadrant of the graph. Because remember, vectors can start anywhere. So I'm going to start right here. I'm starting at negative 14 comma negative 3. So I'm going to go 1, 2, 3, 4 to the right and 2 down. This right here, this is vector v. I'm going to put an arrow on it. Now again, I'm going to go 1, 2, 3, 4 to the right and 2 down. So another vector v. So here's vector v again. And then one more time, 1, 2, 3, 4 to the right and 2 down. So this is vector v a third time. What I have, this whole vector, when you put it together, this right here, from start all the way to finish, this is 3 vector v. So I drew it 3 times. And let's actually count to make sure we got the right size here. So I start from negative 14, and in the x direction I'm going to negative 2. So I have to go 12 to the right. And then I'm starting at negative 3. So there's negative 3, and I'm going down to negative 9, it looks like. So that's negative 6. So notice how 3v, we can graphically see it, is 12 comma negative 6, which is what we got for our example. Okay, so I'm going to leave that up there. And now you try. So suppose vector k equals negative 1 comma 5. I would like you to find these 2 items. I'm not going to read them because that'll give you a clue. Pause the video and work out those 2 problems. So by now you should have paused your video and worked out these 2 problems with the example vector, vector k. So 2k, this is an example of scalar multiplication. And this guy we would read as the magnitude of k. Write that down. Scalar multiplication and the magnitude of k. If you completed these problems, 2k, I just double both components and I get negative 210. And then the magnitude of k, I do the square root of 1 squared plus 5 squared, so the 2 components ignoring negatives, and I get the square root of 26, which does not simplify. All right. Next example, we're going to talk about vector addition. Vector addition. All right, we can add 2 vectors. So for example, I would like to add vector v to vector k. Now you should remember from the previous examples that vector v, I'm using the same vectors here, was 4, -2. And we just used vector k in our example problem, and that was -1, 5. So I'm going to add my two vectors here mathematically. I'm going to start with v, which is 4, -2. And right underneath it, I'll put vector k, which is -1, 5. I'm going to add up the two vectors. 4 plus -1 is 3, and -2 plus 5 is also 3. This answer right here is a vector, and it is called the resultant. We can also draw vector addition. And solve for vector addition graphically. There are two methods. The first is called the tip-to-tail method. And the second is called the parallelogram method. So again, there are two ways to draw vector addition, the tip-to-tail method and the parallelogram method, and we are going to go over them for this example of vector v plus vector k. So here's vector v, here's vector k, and we just got that the resultant was 3, -3. I'm going to start with the tip-to-tail method. I'm going to start by drawing vector v. Remember, these are vectors and can start anywhere. So here's vector v. I'm going to start right here. I'm going to go 1, 2, 3, 4 to the right, and 1, 2 down. I will connect the dots. And this right here is vector v. Next, I'm going to start at the tip, or the arrow end of vector v, and I'm going to add on vector k. So vector k tells me to go 1 to the left and 5 up. 1, 2, 3, 4, 5. Okay, so vector k goes from where vector v ended up to here. So there's vector k. The resultant is then the vector that goes from where I originally started to where I ended up. So that's the vector that goes from here, the original start point, to the end point. This is my resultant. And we can even count that the resultant vector goes 1, 2, 3 to the right, and 1, 2, 3 up. So this is the resultant vector, 3, 3. And we can visually see that. The next method is the parallelogram method. In the parallelogram method, we are going to draw vector v and vector k with a common starting point. So let's pick this starting point right here. Yeah, that should work. Okay, so vector v is going to go 1, 2, 3, 4 to the right, and 1, 2 down. So here's vector v. Okay. And then vector k, I should make the arrow a little clearer. And then vector k is going to go from the same starting point. It's going to go 1 to the left, and 1, 2, 3, 4, 5 up. So here's vector k. Now the parallelogram method says that I should turn this into a parallelogram. So what that means is I'm basically going to make this into a four-sided figure, and I'm going to draw from k something that's parallel to v, and then from v something that's parallel to k, and they should meet up about here. And so here's vector v, this guy is also vector v. Here's vector k, this guy is also vector k. They're the same size. The resultant is the vector, oh, I drew that just a little bit wrong. We want to make sure that they're the same size, so the resultant is actually going to meet up around here. You can see that I didn't go down too. Okay, the resultant is going to go from where I started to where those two sides meet. So that's right here, and we can see that I went 1, 2, 3 to the right and 1, 2, 3 up. So this is the resultant vector 3, 3, just like our answer. Okay, at this point, you try it. You try it. So you try. Suppose, now this is an I. It's an I, but the dot is a vector hat. So suppose vector I is 1, 0, and vector j is 0, 1. I would like you to find the sum, or the difference, for I minus 2j. And I would like you to tell me how your answer relates to vector v from example 1. So at this point, you should pause the video and try to find the sum for I minus 2j, well, the difference, and try to figure out how your answer relates to vector v from example 1. So if you've paused the video to work that out at this point, we're going to do it together. So I want to do 4i minus 2j. Okay. So this is the same thing as 4 times 1 comma 0, so that's I, minus 2 times 0 comma 1. Okay, so I can simplify these. I can distribute. And I'll distribute both of them. So this is going to be 4 comma 0, 4 comma 0, and then minus 0 comma 2. Okay, so now I can line these up on top of each other, and I'm still subtracting. So I've got 4 comma 0 and 0 comma 2. I'm going to subtract them. So 4 minus 0 is 4, and 0 minus 2 is negative 2. So my resultant vector is 4, negative 2. So I can say that 4i minus 2j is the vector 4 comma negative 2. How does that relate to vector v? Well, vector v is also 4, negative 2. So in fact, vector v is 4, negative 2. We can write vector v as 4i minus 2j. This is ij form. I and j are unit vectors. This is a horizontal unit vector. It's always called I. And j is a vertical unit vector. And we can write all vectors in their ij form. So for example, we knew that vector k, I'll do this in a different color. We knew that vector k was negative 1 comma 5. I can also write vector k in ij form as negative 1i plus 5j. And y'all should try drawing those. That's it for this video. Make sure you complete your work on Edgenuity, and thank you for watching.